This video is about comparing fractions. So trying to figure out which fraction is larger given two fractions. Reminder. Again, a fraction is the number of pieces selected over the number of pieces in a whole. Here's something to think about. Which has larger pieces? 4 in the whole or 7 in the whole? Drawings. You can use drawings to compare fractions. I draw fractions a lot, and you know that. So this is definitely one technique that you can use to compare fractions. And whichever whole has the most shaded area, that represents the larger fraction. Now, this is great in some examples. Things like 3/4 versus 1/2. Not so great when the areas are closer together, or we're talking about fractions that are more difficult to draw. So beyond drawing, we're also going to come up with some reasoning techniques. So we're going to talk about 5 different ways that we can think our way through figuring out which fraction is larger than another. Now, these 5 ways will not work for every pair, right? And every pair won't fit nicely into one of these 5 ways. But this will cover a lot of the comparing fractions that happens. And again, this course is about understanding. It's not about steps or the easiest or the fastest way. So I want you to be able to understand each of these 5 reasoning ways. First one, more pieces and bigger pieces. So which is larger, 5/6 or 4/9? So think about what your answer would be, and then we'll talk about this reasoning strategy. So if this reasoning strategy is more pieces, bigger pieces, let's think about what that means. Which of these 2 fractions has more pieces? More pieces selected, more pieces shaded. And which one of these fractions has bigger pieces? And this is where that question about 4ths and 7ths on a couple slides ago came in, right? How do I know which fraction has bigger pieces? Well, I have 6ths and I have 9ths. So the first thing is we need to be talking about the same size whole. If I have a little teeny cake and I have a really big cake, then 6 pieces versus 9 pieces, I can't make that comparison. But assuming both cakes are the same size, and you like this particular kind of cake, do you want that cake cut into 6 pieces, or would you like that cake cut into 9 pieces? Well, if we like that cake, we want that cake cut into 6 pieces because that means the pieces are bigger. So a smaller denominator actually means bigger pieces. Which sounds a little confusing when you say it that way, but if we just think about the denominator as the number of pieces in a whole, well, the more pieces you cut a cake into, the smaller those pieces get. So more pieces, bigger pieces. 5/6 has more pieces. 5 pieces selected versus 4 pieces selected. And 5/6 has bigger pieces. That's what we just talked about. A cake that has 6 pieces in it makes for bigger pieces. So 5/6 has more pieces and those pieces are bigger. Putting those together, having both of those things be true, tells us that 5/6 is larger than 4/9. Now, you might have answered 5/6 and used a different reasoning that was totally correct, and that's fine. Okay, but make sure you understand this one. If you have more pieces of cake and you have bigger pieces of cake, then you definitely have more cake. Okay, so why having just bigger pieces is not enough? So here's an example using money. I have pennies and you have quarters. Who has more money? You have bigger pieces. Your piece is worth more. A quarter is worth more than a penny. But you have quarters and I have pennies, and that's all we know. Who has more money? We can't tell. I could have lots and lots of pennies. If I had 76 pennies and you had 1 quarter, then I have more than you. Okay? So a lot of really small things can add up to more than a few large things. Or I could have 22 pennies and you could have 1 quarter. So I still have more pieces than you have, but I don't have enough to beat your one big piece, right? Your quarter is worth so much more than my pennies that 22 pennies still means I have less money. Okay, so what about having just more pieces? Okay, so again, I have 24 pieces of pizza and you have 3. Before you think I'm a total glutton for having 24 pieces of pizza, who has more pizza? Again, we can't tell. Now, many of you probably read that question and assumed that they were the same size piece. And that's a fair assumption to make. If it's not explicitly said, just be very careful, right? So, I could have 24 plate-sized slices of pizza to your 3 little bite-sized slices of pizza. Well, I clearly have a lot more pizza. Or I could have 24 little teeny bite-sized pieces of pizza, and you could have 3 plate-sized slices of pizza, in which case you have 3 pieces, but you have a lot more pizza because your pieces are larger. So it's important that when we use this reasoning, you must have more pieces and you must have bigger pieces. Bigger by itself, not enough information. More pieces by itself, not enough information. You've got to have more pieces and bigger pieces. Okay, another strategy. So this is our second one. Same size pieces. An example, which is bigger, 2/7 or 5/7? For most of us, these are the easiest. We don't tend to get these wrong. We can think our way through. But let's go with the title. Same size pieces. Why is this called same size pieces? 7. They're both 7ths. 7 pieces in the first cake, 7 pieces in the second cake. If they're the same size cake, they're the same size pieces. So they're the same size pieces, but one fraction has 2 pieces and one has 5 pieces. Well, if I have 2 brownies and you have 5 brownies, and those brownies are the same size, then you have more brownie. So 5/7 is bigger than 2/7. Okay, third strategy. Same number of pieces. For example, which is bigger, 8/13 or 8/7? Same number of pieces. So the 8 and the 8 are the same. We have the same number of pieces. So what we need to figure out is which one has bigger pieces and which one has smaller pieces. Well, we talked about this before. If I have 13 pieces in my cake, those are going to be smaller pieces than if I have 7 pieces in my cake. So 8/13 means 8 smaller pieces. 8/7 means 8 bigger pieces. So one whole has 13, one whole has 7, but they have the same number of pieces selected. So if we both have 8 puzzle pieces, but my puzzle pieces are smaller because I have 13 pieces in my puzzle, and yours has 7 pieces in a puzzle, then they're not the same size. 8/7 is bigger. Okay, fourth way. This way is called over-under. So we can use this when 2 fractions are on either side of a known number. Most commonly we talk about 1 or we talk about a half. For example, 4/3 and 5/6. These 2 fractions are over and under what number? Well, 4/3 is bigger than 1. 5/6 is smaller than 1. 4/3 is greater than 1 because I have 4 pieces and 3 make a whole, which means I can make a whole and have something left over. 5/6 is less than 1. I need 6 pieces to make a whole, but I only have 5. So it's one of those numbers is bigger than 1 and the other one is less than 1, then we can confidently say that 4/3 is greater than 5/6. For a silly little example, okay, you know someone named John, I know someone named John, but we don't know each other. If you're taller than John and I'm shorter than John, then we can say for sure that you are taller than me. Even though we've never met, even though we don't know how tall we are, if we compare ourselves to John, if you're taller and I'm shorter, then definitely you're taller than me. Okay. This is called one away. This is the one that's going to require the most thinking, the most thought process to get our way through. Okay. One away, we're talking about being one piece away from a known number. So here's our example. 6/5 and 12/11. They are both one piece away from what? They're both one piece more than a whole. 6 pieces, 5 makes a whole. I have a whole plus a leftover piece. 12/11, I can make one whole and then one leftover piece. So they're one whole plus one more piece. So then the question becomes is, which of those extra pieces is a bigger piece? Because the wholes are going to be the same size. So really what we're doing is we're comparing those little leftover pieces. So what has a bigger piece? 5ths or 11ths? 5 pieces in a whole make bigger pieces than 11 pieces in a whole. So that one leftover piece is going to be bigger for the 5ths. So 6/5 has a bigger piece beyond the whole. So therefore 6/5 is a bigger fraction. Okay, which is bigger? 3/4 or 8/9? These two fractions are one piece away from, hopefully you said 1. The difference is now we're one piece less than 1. So we're missing a piece from our whole. 3 of those pieces, I need 1 more to make a whole. 8 pieces, I need 1 more to make a whole. So we need to figure out which of those missing pieces is bigger and which one is smaller. So who's missing a bigger piece? Missing a bigger piece. Well, 4ths are definitely bigger than 9ths. So if I am missing a 4th to complete that cake, then I am missing a larger chunk. 4 pieces in a whole makes bigger pieces than 9 pieces in a whole. So 3/4 is missing a bigger piece. So we have to think about this very carefully. It's missing a bigger piece. So if it's missing a bigger piece, which fraction is larger? That makes 8/9 bigger because it's missing a smaller amount to make a whole. See, this is why I said this one takes a little bit more thought process. Okay, so in this case, we're going below 1. We're one piece away from 1. So the bigger piece means we're further away from 1, which means we're smaller. Okay, one away also works anytime both fractions are the same number of pieces away. So the 2 examples I gave were 1 piece away. But if they were 2 pieces away, as long as they were both 2 pieces away, 3 pieces away, any number of pieces away. It can be can be a certain number of pieces above 1, certain number of pieces below 1. And you can also compare it to a half is another common one. You can compare it to any fraction, but 1 and a half, those tend to be the 2 most common ones because they're the ones we're most comfortable with. Another example, 5/8 and 6/10, they're both one piece more than a half. So 8ths are bigger than 10ths. So that one piece above a half is bigger with the 8ths. So same reasoning, we just compare it to a half instead of 1. Okay, so these are our 5 reasoning strategies. More pieces and bigger pieces. Have to have both parts. Okay, same size pieces. We're pretty good with this one. Same number of pieces. Usually we're pretty good with this one. Just think about it a little bit. Not too bad. Over, under, just recognizing that a particular pair of fractions are actually over and under a given number. So look for halves, look for 1. And then 1 away, it's going to take a little bit more thought process on 1 away, but we're looking for fractions that are 1 piece away from 1, either 1 piece less than 1 or 1 piece more than 1, or a half, a piece more than a half or a piece less than a half. Again, we're going for reasoning and understanding, not speed, not steps.